2.4 Operations with functions. The first thing you must know how to do is to find f plus g and f minus g. F and g represent functions, and here they are in the first example. F of x is 9x, or just 9 minus 3x, and g of x is 5x plus 7. What we are going to find first is f plus g. That means you add the two functions together. That would be 9 minus 3x plus 5x minus 7. Add like terms, we have a minus 3x plus 5x, which is 2x. And 9 minus 7 is 2. That is f plus g. To do f minus g, you're going to have to do 9 minus 3x, and since you are subtracting a quantity, you must do minus the quantity of 5x minus 7. Simplify that. Distribute the minus sign outside of the quantity to get minus 5x plus 7. Negative 3x minus 5x is negative 8x, and 9 plus 7 is 16. Negative 8x plus 16 is the solution for f minus g. And you must do both of them. The first thing we have to do is f plus g. So that means we're going to do 2x squared minus 6x minus 3, and then plus a negative 3x squared plus 4x minus 2. 2x squared plus a negative 3x squared is a negative x squared. Negative 6x plus 4x is minus 2x, and then negative 3 minus 2 is minus 5. That is f plus g. You now have to do f minus g. And f minus g is 2x squared minus 6x minus 3 minus the quantity of negative 3x squared plus 4x minus 2. When you subtract a quantity, you must insert it into parentheses and put the minus sign out in front of it to the left. Simplify first. This out here to the left can stay for right now, but you must distribute this negative 1 to each item inside, changing the sign. So you get plus 3x squared minus 4x plus 2. And at that point, you can combine like terms. Or a positive 2x squared plus 3x squared is 5x squared. Minus 6x minus 4x is minus 10x. Minus 3 plus 2 is minus 1. In order to get this right, you must have this, and you must have this. You must do f times g and f divided by g. And you have to state any domain restrictions that might come up. The first thing we want to do with this problem is to multiply, and that is f closed dot times g, and that dot will become important later on. F times g is simply x squared plus 9 times the quantity x minus 9. This goes back to Algebra 1. FOIL. First outside, inside, last. Multiply these to come up with x to the third minus 9x squared, and then go to your 9 and multiply those. And you'll have plus 9x minus 81. There is nothing to simplify here because you have no like terms, and there are no domain restrictions because there's nothing that you couldn't put into this function. Domain restrictions show up mainly whenever you have division by an expression with a variable in it. This is f times g. F divided by g is what comes up next. And f divided by g is x squared plus 9 over x minus 9. There is a restriction on this expression. That expression is not valid if x equals a certain number that will make the denominator 0, and you cannot divide by 0. What number can I put in for x such that it would make the bottom 0? 9. So x cannot equal 9 right off the bat. When you go to divide this, you should see if anything can be factored out of the top and the bottom. That's a sum of two squares. You can't do anything with the top. That's from Algebra 1. On the bottom, you just have x minus 9. You can't factor anything out of that. So this one cannot be reduced. It's just x squared plus 9 over x minus 9. You must find f times g. And to do that, you will have 5x squared times 1/2 x. 5 times 1/2 is 5/2. X squared times x is x to the third. That is f times g. And next up you have to find f divided by g. So that would be 5x squared divided by 1/2 x. Right from the beginning, what number could x not equal such that it would make the denominator 0? Huh? 0 is right. So x could not be equal to 0 on the bottom. And anything else you put in for x will not make it 0. Now you have to divide. You have 5 divided by 1/2. That is 5 over 1 times 2 over 1. Divide by 1/2, you multiply by 2 over 1. X squared over x cancels to just an x on the top. So you have 10x. There is no division by anything here. So there's no restrictions on the new equation. On this problem, you have to find f divided by g. That is 4x plus 8 over x plus 2. As it is written here, what number could you put into the denominator that would make the denominator equal to 0? -2, so x cannot be equal to -2. Is there anything I can factor out of the top? (4x) and 8. What is the highest number that comes out of 4x and 8? 4. 4x divided by 4 is x. 8 divided by 4 is 2. On the bottom we still have x plus 2. X plus 2 over x plus 2 cancels, and you're left with 4. We're not working this one all out. You can find f plus g, just add the functions together. But when you find f plus g, you must insert -3 into that new function. It can be done quickly. If you add this function with this one, 6x plus 2x is 8x, and 8 plus 4 is 12. That is your new function. This is what you're inserting into it. So it's just a matter of 8 times a -3 plus 12. That's a -12. For this, you have to find the following. F of g. F of g of x. Notice it's an open dot, not closed. That is not multiplication. It is f of g. That means that whatever you have for your g function, you're going to insert that into x in the f of x function. The f of x function is 3 times x plus 2. Here's the parentheses for the x and the plus 2. The g function is negative 2x minus 6. Simplify. So you come up with negative 6x minus 18 plus 2. Negative 6x minus 16. F of g of x is different from g of f of x. In this case, you're plugging the f function into the g function. The g function is this, negative 2 times x. Notice the parentheses for the x. You're plugging in the f function, which is 3x plus 2. And then simplify. Negative 6x minus 4 minus 6. Negative 6x minus 10 is the new function.